Guys, welcome to our unit on organic chemistry. Organic chemistry is very, very unique, and it's a huge topic. So we're going to just try to get the information to you. Most of the information that we're going to talk about in terms of naming and functional groups, guys, is in your reference tables. But I want to kind of talk about the basics here in this video, and then we'll kind of go throughout it. So it is a lot of information. The biggest thing you got to remember and to know is how to use your reference tables and kind of the basics to kind of understand the naming pieces, because you will be asked to kind of name or identify certain functional groups and structures. So that's kind of the goal of this unit. It does seem like a lot, I know, but it was a piece that showed up on last year's Regents, and I know my students struggle with it, so I want to spend some more time with it this year. Organic chemistry, guys, is the study of compounds that contain carbon and hydrogen. Now, we've kind of talked about that term before. Those are called hydrocarbons, and we've talked about it when we talked about combustion reactions way back in December. So we're going to talk more about those in this unit as well. So why is carbon so special? And if you look at it on the periodic table, it's in group 14, which means, hey, is it going to lose 4 or gain 4? So it's really the best sharer. So because it has 4 valence electrons, it makes it very unique that it wants to be the best sharer there is. So these 4 single bonds spread out to evenly create what's called a tetrahedral molecule. All right, that prefix tetra we've talked about before. Like Tetris, every shape has 4 blocks in it. That's what carbon's doing, is it creates this tetrahedral that's shown down below. All right, so it's very good for sharing. Carbon atoms share those electrons with others. All right, with other carbon atoms, they could form covalent chains, which we're going to get into, or rings, or networks. Now remember, this is a good review here, guys. These networks, these are called network solids. They are the strongest bond type. Right? Rest of covalent bonding is not super strong, but those carbon networks, like silicon dioxide, all right, it's been a little while. I want to make sure we review that. So silicon dioxide is like sand or crystal. And something like diamond. Those are the 2 biggest ones that you will see on the Regents. Point D, 2 adjacent carbon atoms can share up to 3 pairs of electrons. Okay, so that means they can form triple bonds. Each shared pair of electrons is represented by a dash line. This is going to be something that's not new, but you'll see how it can be a little bit new when we start drawing structures. So hydrocarbons, guys, they are organic molecules that only contain carbon and hydrogen, so C and H. Now, the first term you've got to understand and you've got to make sure you know. Okay, I'm going to kind of try to point out big things to make sure you kind of highlight and remember. And saturated is one. Okay, saturated hydrocarbons, guys, they are all single bonds. So when you look at a structure, it's only single bonds that you see. All right, they have the maximum number of hydrogen that can be attached. All right, so that's the same way a saturated solution, right, holds the maximum amount of a solute. That's what's going on here with a saturated hydrocarbon. It has the most amount of hydrogens possible. So you have a single dash line, so something like this, if you had 2 atoms where you have 1 dash between them, all right, and there's a single bond. Again, this should be nothing brand new to us. It should be a review. We've seen single bonds before. We've drawn them when we've drawn structures, which is something we'll come back and review more when we get closer to the exam. So 1 shared pair of electrons, right? That means 2 electrons total. That shouldn't be anything brand new to us. Another way we could see it drawn, guys, is with 2 dots between them, right? This one right here with the line, that's going to be the most common. But if you did see dots, don't stress out. Just understand, hey, that just means a bond, okay? So make sure you know that term saturated. I encourage you to highlight it. I'm going to be highlighting certain things as we go throughout these videos to kind of make sure that you keep those in your mind, the big ideas. So this would be an example of what's a saturated hydrocarbon, guys. When you look at every single atom, there's no double bonds between them. It's all single bonds. Where now if we start getting into unsaturated, okay, that's another term you got to make sure you know, unsaturated. Oops. So there is at least one multiple bond. Now that multiple bond could either be a double or a triple bond. Okay, so two dashed lines, right? Something like this, where you have a double bond. Think to yourself, how many electrons are within a double bond? Right, you have two shared pairs, which means you have 4 electrons total. So it could be written like this, okay? And there's your example. You can see it right here. Now we're going to get into all the naming and what type of compounds these are in the forthcoming videos. But for now, we're just trying to get the basics down, okay? And then if I also have 3 dashed lines, again, what is that? We've seen it, okay? That means we have a triple bond, right? Again, nothing brand new here so far. Where you have 3 shared pairs, what's the total number of electrons? And that's the thing where you could get tripped up on the regents. You may understand that, hey, there's 6 electrons total in a 3 shared pairs, but make sure you answer the question that's asked, okay, that they're asking you. All right, and that's what you would see right there is that triple bond. So again, anytime you have multiple bonds, it means you have an unsaturated compound, okay, hydrocarbon. So properties, guys, we're going to kind of roll through these really quickly, okay. Something to note, make sure you know, kind of have the gist of these. Bonding, they are covalent or molecular, which we've already talked about. So mostly all nonmetals. There might be some examples, but pretty much for you guys in this class, there's not going to be any metals with it. Solubilities, most are insoluble, meaning they're not going to dissolve in water because they're generally non-polar, right? This saying, it's been a while since we've talked about it, likes dissolve likes. It's something we're going to spend time in review for the regents. We're going to come back and talk more about that. Conductivity, they are mostly non-conductors, all right, in their states. Only organic acids, which again, that term acids, we know, hey, acid will ionize, acids and bases form electrolytes in solution. All right, so these are poor conductors, these organic acids. Poor conductors, something like acetic acid. Melting points, they have weak intermolecular forces. Again, IMFs we will come back and talk more about as well. So because they're weak, that means they have low melting point / boiling points. Their reactivity rate, guys, they react slowly, and I mean really slowly, because they have high number of bonds a lot of times, very large structures. I know when I was in grad school, people in the organic labs down the hall from me, there's lots and lots of steps involved, and they would have to run their reactions for like maybe 30 hours at a time for it to even get, 40% yield. So lots and lots of steps, okay? Now, big thing, molecular formulas versus structural formulas. We've talked about it a little bit, but we're going to come back again. Molecular formula, guys, shows the number of atoms. So this is when you write a formula out. So like H2O, you're showing the number of atoms. You're not drawing the structure. So you're showing each element, okay, and how many they have. So something like propane, by name C3H8. We'll talk more about the naming here in the next couple of videos. Structural formulas, however, they show the number of atoms of each element, and they also show the arrangement. This is where you have to draw it. So something we're going to spend time again kind of going back and drawing bonding and drawing Lewis structures, okay? This is going to be kind of that precursor to kind of get us back in that mindset. Okay, so something like this. This is the most informative formula because we can count up, okay, I have 1, 2, 3 C's, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So you can get both from that structure. Now, this is where it's drawn out completely in the structural formula where it shows all the different bonds, but we also have this thing called the condensed formula, which is the combination of both the structural and molecular formula. kind of a hybrid between the molecular and the structural, all right, where we show the carbon numbers with its constituents and then the hydrogens with how many they have. So this doesn't show each individual bond, but from this we could say, oh, well, there's 3 hydrogens around this first carbon, there's 2 hydrogens around the second, and then the other, it's attached to the other carbons, and then this guy has 3 hydrogens and it's attached to a carbon as well, which is where we get this formula right here. So as we go through and we start writing structures, guys, and we do some naming, we'll get into those a little bit more. So what I want you guys to do right now, okay, is I want you to try to write the molecular and condensed formulas for all of these. So I'm going to do the first one together. So if I count up, I've got 1, 2, 3, 4, 5, 6 carbons. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens. All right, so that's how I would get my molecular formula, just count it up. The condensed formula now is, okay, this guy, he's got CH3, then I've got this guy, CH2, this guy, CH2, this guy, CH2, this guy, CH2, and then the last guy is CH3, okay? So I want you guys to pause the video, try doing these next two, and see how you go, okay, how you do from there. All right, next one, 1, 2, 3, 4. I've got C4H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, H10. Condensed formula would be CH3, CH2, CH2, CH3. All right, molecular formula here, I've got 1, 2, 3, 4, 5, 6. C6H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, H12. My condensed form would be CH3, CH2, CH, CH, CH2, CH3. Okay. Now, by seeing this condensed formula, guys, like this, that gives us an idea as to, hey, there's got to be some double bond or triple bond in there. So keep that in mind, okay, as we go through it. Now, one thing I didn't point out, guys, open chains, where they're just a long, long chain of atoms kind of stuck together. That's called aliphatic, okay, aliphatic. That's a term you need to be familiar with, okay. Aliphatic just means a long chain, where aromatic means it's a closed chain, okay. So the molecular formula here would just be 1, 2, 3, 4, 5, 6, C6. If you count up the H's, you would get 12, okay? Now, this is something not only with organic, guys, but it's with all bonding, but remember, when drawing organic compounds, you must always have 8 electrons around each atom, okay? So those are in bonds. The only exception is hydrogen, right? Hydrogen is only going to have 2, and again, that should be review for us. We spent a whole unit dealing with bonding, so this is kind of that first precursor going back to that, all right? So keep that in mind. All right, I know this is a little bit longer, kind of throwing a lot of information at you guys, but we got to get through it before we can start talking about the other types of compounds. So guys, table Q, we're going to talk more about table Q in our next video, next couple of videos, okay? This is where you have a little bit, or a big portion of information, which is why you don't have to memorize all this with organic, but you are given it on table Q, okay? We're going to talk about these 3 family groups in the next few videos, okay, and kind of talk about what those are. But the big thing you want to remember, guys, homologous. Homo, right, same. It's a group of related compounds in which each member differs from the one before it by 1 carbon unit. Okay, so the next few videos are going to be dealing with homologous series, alkanes, alkenes, and alkynes. So we'll talk more about that later on. There are always 4 bonds, guys, around carbon, and H can have 1 bond. Highlight that. Make sure you remember that. Carbons will have 4 bonds. Hydrogens will only have 2. So they'll only have, 2 electrons. So 1 bond, 2 electrons. Now, the other prefix that we have here when it starts with naming are all the organic prefixes. So 1 through 10, again, you don't have to memorize them. You probably will know a lot of them. Meth, eth, prop, bute, pent, hex, hept, oct, non, dec. They're all listed there for you in table P. Again, know where to look for that information. So we're going to convert these using those tables. It's kind of the precursor to the next couple of videos. So C3, guys, if I'm looking for carbon 3, okay, number of carbon atoms, that's prop. okay, prop, and then it's H8. So we're going to use these formulas. Okay, the N is the number of carbons I have, and then I'm going to plug it in. So 2 times 3, okay, plus 2. All right, since I have 3, I'm going to plug it into each one of these formulas. Oh, there's 8. So I know I have an alkane, so my name for this one is going to be propane. Okay. Oh, look, propine. Pro still means 3, so I know I have C3. I got to figure out my H's. I'm going to look up here. Ine, alkyne. Oh, here's my formula to get my H's. It's going to be 2 times 3 minus 2. So that's 6 minus 2, which equals 4. So it would be C3H4. Okay. So try using table P and table Q. We're going to get into more details with it in the next few videos, so you're going to get lots and lots of practice. But this is something you will have to do on the reagents. Okay. So C4H8. Okay. Notice it's 2N. Right. So that's my alkene. So this is going to be butene. Pentene, 5C5, ene. That means I'm going to plug it into this alkene formula, so it's double that, so H10. C6, H10. C6 is going to be hex. Now 10, I got to figure out, well, okay, which formula will that follow? All right, it's going to actually be this guy. So 2 times 6 minus 2, that's 12 minus 2 equals 10. That's how I get my 10, so it's hexine. It's going to be my ending. And hexane, so C6, ending ane is a alkane, so it's 2N plus 2. All right, so 2N, 2 times 6 plus 2, so 12 plus 2 equals 14. Again, we're going to get into them more specifics, guys, in the next couple of videos. All right, but I wanted to introduce it to you now. So until next time, I'll see you later.